You see this icon, which is of web. So here you see web application. Like that, when you set up for the database also, you'll have a database, cache, function, serverless, and some custom applications. So right now I set only for the one web applications. So this is the one. Now let's go through the slides. It will be easy for me to explain because flow will be there by the time. So let's get started. So Datadog, we understand what is that. How do we get started? We understand host based, we are doing it, we know that. And container based also is available. So container based, you have to do what, you know what, you have to load that DD agent in the image itself, Docker image. And Lambda and all, it should be in form of functions. Some Python functions will be there, or Java class path call and all. So that is also possible. So now some of the terminologies probably more or less we discussed in the last session. What is a service? So service is something like this. It can be DB service, it can be web service, it can be cache service, it can be functions. So like that, in reality, you know, right now I have one, but in reality, we'll have a 200, 300 applications lying here. And that's the reason we have so much of filter here. See here, these are the filter you can use now. So because of that, so you can filter that a lot of services will have it. And you can filter by type, you can filter by last deployed, you can filter by watchdog. The watchdog I'll discuss a little bit later. Monitoring status, whether you have some alerts. So alert we have not set it up, but we'll set up tomorrow. And infra types, whether it's a Kubernetes, Docker, Fargate, host. Right now we have a host type. Here it says no infra data, only one. So here, this no infra data should be coming in the host. Maybe some tag is missing. So because of that, so infra type and so on. And you can also filter. And here you have a timeline. I don't think so I have to teach you. Here individual traces, all the traffic you can, it's like a huge, request. Each request you can see at here. Right now 404 error is coming. That is good. 404 means, why this 404 is coming? Clear. Not everything is 404, but some of this 404. So I think maybe some of you have down this Tomcat, or maybe my applications. I'll just need to check. So some 404 is coming, 200 and all this thing will come. Okay, so this is the stuff. Now services here we were talking about, and let's move on with the slides. Resources. So resources represent a particular domain of customer applications. They are typically an instrumented web endpoint, database queries, or background job. So what is the resources I'm talking about? So if you go to the service, this is a service, Deloitte chat. Okay, just avoid the spelling mistake. Okay, I know this is spelling mistake. So here, where is the resources? So resources is nothing but somewhere you see this is the resources. So where the traffic, which endpoint the traffic is going on. Are you able to understand my things, right? All of you? All of you? Hello?
Yes, Rajesh. Yeah.
Yeah. So these are the endpoint. I got a traffic 404 too much actually. I don't know why this is coming. For what reason? I need to look at it in a detailed way. But yeah, so these are the requests which is coming to the server, and everything, whatever the response you have, it's gathering. Okay, so 404 is too much. Okay, I understood this. Why 404? Because AWS has detected this DDoS attack. It's called DDoS attack. Okay, right now this is not a genuine user is hitting. This is hit by a JMeter. So AWS has some security in place. So they decline that URL request. Okay, so that's reason 404. So this is how the people do the DDoS attack actually. So DDoS attack, do you understand, all of you? DDoS attack?
Yeah, denial of service.
Yeah, so like that. So this is the stuff. Now this is the resources. So let's move on. So now
what is that P50 and P99?
That's a P means percentile. This will discuss it sometime. P means percentile.
Okay.
P50, P99, P70, P80, P90. These all are percentile. So that means for this endpoint, there were total 16 requests and total time which was spent is this one. And then P5 is 1.98 seconds. So percentile 50 is 1.9. So now what is the percentile? I'll put it in a simple way if you are not comfortable in going further. Okay. So monitoring. So what you are monitoring basically? Monitoring means in Datadog, I'll put it in a very simple way. Monitoring means alert. Simple. So where do you see the alerts? So alerts which I was showing you earlier. Okay, by mistake. This is mine or someone else? I think this is not mine. Sorry, I was looking at someone else. Yeah, this is mine. Huh. So for him, I think it was from Mukesh, I guess. So for him, there's so much of error, but for me, there's not much error. So I'll go for 15 minutes. Okay, so where is the alerts? So alerts you can see at multiple places. Right now we have not set it up, but if you go to the service level, here you see the alerts here. Okay, and for each services also there is some alerts or not. So if you see that here, monitors, you see the tab, monitor column. So if you set up alerts and some of this will violate, then here you can see the monitors. Are you able to understand, all of you? Hello?
Just please repeat what we'll see under monitors.
Monitor is equal to alerts in Datadog.
Okay.
That's all. So here you can see the monitoring and alerts. If hit the alerts, then you will see that number of alerts. Right now we have not created alerts because tomorrow's stop. Okay, so that is something. Now traces. What is a trace? I told you traces like individual trace, individual traffic, which you see that here. I'm getting 500 euros. It's a server error. So I'll just delete this. Okay, so save it and run it. So 500 errors I'm getting. I deleted that request, async and whatever it is. So now you'll have a different things. So yeah, this is the terminologies. Now span. Span means once you click on the trace, let me click on this trace, some successful one. Let's say this one. And now you see that whatever that you see that from here to here, this is called span. That means to process this, it has spanned. Any idea what is this sign for? 364. Do you see that 364 in the green bar? What is this? Microsecond. Okay, so that is span for this. So right now there's only endpoint, but what will happen? You will see in the real time if you look at the some production boxes, you know. So you will see something like this. I'll show you this visualizations. So here you have one box, and then here you will have another call. Here you will have another call. Here we'll have another call. So now it will say this is a one span. Then you'll have one span, this one span, and like that. Are you understanding, all of you? So here you see a span list. There is only one right now, but you will have a multiple if it is like that. So each call you can see the span, duration, execution time, percentage of time it has been taken from the overall. So this is called span. And top level span means first call. Trace matrices. Trace matrices means each trace how much. So how much CPU and how much RAM has consumed. So let's say this is the trace. Okay, this is the trace. I want to know how much CPU and matrices has been consumed. So you can see the infrastructure tab. See, this is the CPU for only for this trace. Okay, only for this trace. So like that you can see that and get it done. So you can see the matrices also, and here you can see map. You can open in the full page, you will see better details. So this is the individual trace full page options you have it. So you have a little bit more detail about this. So here you see this what process the response time is 364 microseconds, and there's some information here. You have infrastructure detail, matrices, logs we have not enabled, process we enabled actually. So here it is. and hotspot we have not enabled them. So this is the service mapping. You see that uh, the average request response time is 47 requests per second. Latency is 678 and only for this trace. Okay. Right now, not too much of data is there because it's not calling multiple functionality. Okay. So yeah, indexed span, it's also same as part of this. Span tag, you can tag it, retention filter, ingestion control, sublayer, and execution duration. So these are the things which you have to understand. I'm skipping it. Now I'm focusing more on the dashboard. So let's go to the dashboard, which is here. Now, first thing which we need to understand, this is the watchdog insight. Now this it was not earlier actually, but they have added here watchdog. So earlier watchdog was the window which you see here, watchdog. Now, of course, the question is what is watchdog? I'll tell you this one. Watchdog is not you can control. Datadog controls that. They give you some insight about it. So I'll talk about data watchdog later. But this is something some service summary. Okay, this we have to understand. So here you see so many graphs. Now I would like you to tell me. See, this is the one graph you need to understand. Okay, there's another graph you need to understand this one. Okay, then you have to understand. Sorry, you have to understand this errors graph, dependency map, and many things. So these are the important graphs. Now I have a few questions for you. What is this? Anyone remember, recall? What is
version 1.0
Where did I set?
Catalina
Huh.
in
So next time, if you think you have deployed after 1 week, you deploy the second version, what you should do?
Change the version up.
Wonderful. Yes. So then you'll ask Rajesh, what is the benefit of it? So you can compare the performance between the version 1 and version 2. But how? So here it is. Do you see the deployment somewhere? Here it is. So right now I have only one deployment, and you see that you can see the difference deployment. You can compare version 1. This is the 2 hours ago, and this so this is the 2 hours ago. This many request, error rate, and da. Here you have a version 2, version 3, version 4. You can compare which version deployment is working and healthy for giving the better response. If it is a later version, it has no improvement, then you can do whatever you want to do with development, right? You will escalate and all this stuff, correct? So this is the stuff, small things which will make a lots of difference. Yeah. So error tracking issue 1. So here error tracking which is coming from here. So I have only few errors actually. That's the reason it's coming. Now SLO you see here. What is SLO means? Anyone would like to tell me?
service level objective which is set for an application.
Right. SLO means, for example, any you guys only can share with me your knowledge. So through SLO service level objective you set for your application. What else after that?
We need to ensure that the application doesn't go that beyond that. In case if we have more issues, the error budget starts get utilized, and in case it gets utilized 100%, we are at risk of. I mean, basically, SLO we look at from availability angle on observability side, so that we don't miss SLAs. And it is usually set a little with cushion with what SLA has been agreed upon with the customers.
Yeah. So guys, so there are 3 keywords in SRE world you have to hard code. One is SLI. I means indicator. So these all are indicator. That means these are the matrices you will get it. Here you get, okay, what is the realistic things which you have? Okay. So what is the realistic things which you have? Okay. Now, second thing is SLO. SLO is set by the project team itself. So SLO is set by the team, and you say, hey, this is my application, and I am taking the personal objective to serve you this response time. So you will set a SLO, and now SLA will be set by you and your client. So SLA is like service level what is this? Agreement. Okay. So now see, there is a things SLI, which is here, SLO, which you set, SLA, which is agreement. So why you set SLO? Because it should be under SLA. Let's say use commit, and in the dumb way I'm telling, your response time is, let's say, 10 seconds. Agreement, you have committed to your client. So you will set SLA something like 8 seconds. Now, whatever the reality, if it is not matching, then you will see the SLO break. Okay, so that's something. But in this is the dumbest way to set. Typically, you set in the percentile way. Like SLA will be set 99.9 percentile. It should be 200 requests. Okay, or response time it should be less than 1 second or something. But accordingly, you set up SLO. Now the question is, okay, you can do all this thing, but where to set up SLO? So actually in the monitoring front here, SLO. You can set SLO for these services because monitoring is tomorrow topic. I'm not talking about. And here you have incident, means some of the observation which you detect, you can declare the incident also. Okay, so you can create a new incident, you can go to the incident, configure the incident, all these things you can do that. So all the incident for this particular application, delete chat, you will have it here. Now the question is where the incident you can consolidate it. This for this one, right? So here under the monitoring itself, you have a incident which is, you see here, all incident, new incident, all incident, new incident. So yeah, this is the way you see that. Now the question is, what is the request and errors? Request per second by version and request and errors per second. I think if you spend little bit of time understanding this picture, you will get it actually. That's not a very big deal to understand. But yeah, this is something which we need to understand officially. So yeah. So first thing, you have these three button. You will have it. One for the viewing the full screen, another one where which you can export to dashboard, which I'll do that tomorrow. Export to notebook, export to the incident, and blah blah blah, and declare incident. So here, where is that? This, you see this one. Declare incident means there's some problem in this. You want to declare as an incident. You want to export to the this graph. You want to export to the dashboard or notebook or something like that, or you want to make it in a field view. So that's something which you have to get comfortable. Slowly, each and everything you have to notice it. So now here we see the total request and request per second. So here, if you see here, now you see that here in this particular time, request per second, here you see total hits at that particular time for the 10 seconds window in 17.17K per 10 second. That was a request. Okay, here it got reduced to the 577 request per 10 seconds. So now if you want to, you can play with this graph. It's a very intuitive graph which you can enjoy. See here, and here also automatically will get changed. You can see the lots of other stuff also. So slowly I'll just set this 15 minutes. It'll be easy for me. And so here, do we have errors? So you can disable. You see here how many errors you have. So there were 40 errors here, and this time you see that, and this is also 40 errors. So like that, you can see the number of errors also. So you want both. So enable this, and so now you see that errors are not coming. Why? Because errors are so small here that graph is consolidated. 18,000 requests, out of which only 14 errors. So that's the reason it's not showing. But if you hover over there, you will see that errors here. Okay. So all of you are able to understand that, right? Correct? Yes, all of you. Hello.
Yes.
Hello? Yeah. So now this is a request and errors. Now, if you see the request by version, right now I have deployed only one version, which is the V1. So you can see, you can follow my cursor actually. See here, there's only one version. So right now 1.0. But actually, in realistic, if you deploy multiple versions, so you can see, okay, what are the versions which you have for this? So this is a 1.1, 2.0, 3.21, something like that you'll have. So you can see the request by version, how many requests you got it in this version 1, version 2, version 3, and you see the response time for that number of traffic for that particular time, and you see that which is doing well version 1 is doing well, version 2 is doing well. All this analysis you can do it very well. Now here, request per second by version. Okay, so only one version. So here per second request here you see. So I see here 1.62 request, here 1.83 request. Here I stopped it probably. So here you are very little, and so on. And here request and error per second, probably by the way you read it, you'll understand. So all of you understand with this graph? Any problems which you have working and understanding this graph?
No issue.
Okay, so now we'll go for the latency. Now here you have so many things, guys. Okay, latency, historical latency, latency distributions, latency by version. So what is a latency? So latency is like what is your time which you are spending for the request. Okay, so typically latency we represent in the percentile. So here you see P50, P75, P90, P95, P90, max. All these things are there. Okay, so you can disable some of this. You can play with it here. Okay, I disable everything. Only one thing is there, max, correct? And P90 only, P95, P90, P99, P75. So like that you can see that. Okay, so also go for max. Done. So all these thing you can see. Now remaining thing you are not able to see because this some of the request which is so low. So what you can do is you can disable some of those. Only see you want to see P90. This way you can see that here. Okay, so like that you will see that. So now the question is, what is this? So latency is like one of the topic which you have to get into that. But right now I want to explain you in an easy way, and because I have a very limited time, so easy way, and that is just a second, latency. So just give me 2 seconds. Just give me 2 seconds because I don't want to cover entire thing because no time also is there, and also I don't want to complicate the stuff. So, guys, see here, understand this slides. So this is the latency table. So here, these tables will define how many total requests for the certain duration. Let's say for 1 second or 1 minute or 1 hour, whatever you set the duration, whatever it is. Let's say 1 minute. In 1 minute, how many total requests you got it, where the latency, that means response time, was 1 second. So how many total requests? 5 requests. How many total requests you got where the response was 2 seconds? 5. Response 3 seconds? 10 requests. 4, 40. 5, 20. 6, 50. 7, 4. 8, 1. Did you understand this table or not? Tell me.
Yes.
So now, guys, total number of requests, how many? Tell me. Total number of
Add the number of requests.
Yes.
Column.
What is the total number of requests? What is the total number of requests?
100, I think.
100. Yeah. So
yeah,
why 100? Because easy to understand. So now this is the table which is being created here also. This is the kind of this algorithm actually. Okay. So they will decide what are the number of requests got loaded in this number of time, that number of time, and also like that. Okay. Now the question is, how do we understand this P70, P50 and all? So now it's very simple, guys. It's very simple. Let's understand. So here, if you see that, when I say what is a P99, so P99 is my 7 second. Tell me how I calculated.
99% of the request was served within 7 seconds.
Correct.
Only one request was more than 7 seconds.
So when someone asks you, let's say your manager say, hey, Rajesh, can you tell me what is a P99? P99 means out of 100 requests, 99% of the request got loaded in the latency. That means response time was lesser than the 1%. So what was that? So mine was 7 seconds. Correct now? Because from here to here, if you calculate, it's a 7 seconds. This is a 1%. Are you understanding, all of you? So now I'll ask you one more. Tell me one thing. If my manager will ask me, hey Rajesh, can you tell me percentile 95%? What is a P90? So what is the response time for P90? So what I would respond? Tell me. P95. Tell me P95.
15, 6.
6 seconds. Yes, you guys are getting now. So this is the way percentile. That means what? P95 means 6 seconds. That means 5% of the users are getting response time more than 6 seconds. Now you have to focus on these 5% people and find out why this 6%, why these people, more than 5% of the people are response time is more than 6%. So that is the what you will see that here you will see, okay, now I want to know what is a P90. P90 means my 90% of the people are getting loaded the response time in this many microseconds. That means what is a P99? Oh, P99 is pretty huge. Is 1.1 millisecond. Millisecond versus microsecond. That means 5% of people are getting this more. So now what you will go and what you will do, you will go and check why this 95% is coming. So you will see that all this application, why this 95% is coming, what are the reasons for it. So at the resource level, you will go and troubleshoot that for that particular. Are you understanding this graph, all of you? All of you? Hello? I'm audible?
Yes, sir.
Yes, you are.
Rajesh, yeah.
Okay, so now what is the errors? Here you have errors by version, errors per second by version, errors per second, percentage of error by version, percentage of rate, all these things. The moment you read it, you understand this. So let's go 1 hour. So I have an error percentage. See, errors total 140, I got it. What is the percentage rate for it? 0.1. That's a very healthy actually. 0.1%. So error rate by version, in fact, you have only one version, so it will be same. And error per second, how much? So it's very, very less. So you're on 1.7 errors per second, whereas errors per second by version, this one. So you'll see that. So now how the error is important? Anyone would like to tell me in SRE context? In SRE, when you set the SLO and SLA, then you write a errors agreement also with your client, saying that, okay, I will not have error more than this percentage or this many errors per second or something like that. Are you understanding? All of you? Okay. Now dependency map. Dependency map, right now we have only one. Why? Because there's no database call. But actually, if you monitor APM, do that through the database. So this website will show you this one. And if you do through gateway like payment gateway, so you'll have a something like this image. Okay, this is called dependency map. New Relic, we call it service map. Okay, so here it will say like that. So when you have a real time in things, you'll see that. So at the each service, you can see number of requests, what is the latency, what is the error rate. You can and click on it, and you can. Anyways, you get the same page actually. Now this is these are some of the bars which you understood. Now there's one bar which I'm missing. I feel missing. Where is that? Okay. Appdex.school. This is something important. So Appdex.school is a formula. Okay. So how do we understand? Anyone have idea what is Appdex.school? Anyone? Hello, I'm audible, right?
Yes, sir.
Yeah, guys, focus on it. This is your most important thing. So Appdex score. So guys, what is Appdex score? So Appdex score, first you see that. I will ask you a few questions, you have to respond. So that way I'll be also be aligned with you guys. So Appdex score, what is the minimum, what is the maximum range? Tell me.
It is between 0 to 1.
Wonderful. So guys,
1 being more productive, 0 being less productive.
so Appdex score, you answer my question. Its range is this one. Now, what is my current Appdex score? Anyone would like to tell me?
1.
0.99.
No, here it is.
Yes.
Correct now? Now, this you have to understand. What is T? I need to explain it. Okay. Now, the question is, what is Appdex score? So, guys, Appdex score will tell you whether the end users are satisfied with your application or not. Okay. Your end user, your customers are satisfied with your, if it is closer to 1, it is satisfied. It is closer to 0, not satisfied. Okay, so this is it's a good number, 0.99. That means 99% of the people are satisfied with your request. I mean your application. Now you will say, Rajesh, how this is being calculated? So for that, we'll have to check. Yeah, some question. So for that, we'll have to understand this. So guys, look at this image, very simple image. Okay. So you have a request, HTTP request to the service application, and then response, you get it. Can I call it this as a R in millisecond? Can I call it? It can be millisecond, it can be second also. Can I call it R? Hello?
R will be too much.
No, R means
Alphabet R.
Oh,
R.
okay. Yeah, sure. I thought it's number of hours.
Yeah. Can I call it R? Request time R in milliseconds?
Yep.
Okay, good. Now, guys, let me ask you one simple question. Let's say you are a developer for the application. So who would tell me what would be the response time? Me or you? Let's say I'll ask you, hey, you are a developer, and I'll ask you, hey, if you have a 10,000 of people of traffic, what is the response time you are expecting from your application? Because you will you did the testing, right? You would tell me, okay, under the 10,000 response time will be this, under the 20,000 response time will be this, under 5,000 response time will be this. Correct now? Hello?
Yes.
Yes.
So you are a developer, you will tell me. So can I store that response, your response, developer response time, which is as a T? Can I call it T?
Like a baseline.
Yes, that's the baseline. And who said T? You said T. Developer said T.
Mhm.
What is R? R is a real numbers. R is a request time, which is a real. So R and T, if you understood, then I'll talk about next. Understood?
Yep.
Okay, wonderful. So now what happens if the request time is less than and is equal to T? That request is considered to be satisfied request. If request time is greater than T, those number of requests is put in the bucket called tolerating. And those numbers, if it is R is greater than 4x of T, then those people are frustrated with your application. So we got the satisfied people, we got the tolerating people. that satisfied people who's satisfied with your application, and we got the people who's tolerating with your applications, and those who are frustrated. Understood? So far, so good.
But who decides this 4 times t?
This is the algorithm. Okay, you see, R is a real, T you set it up. So if R is greater than 4x of T, then
It can
those
be
people
3x.
are
It can be 3x or 5x, right?
No, no,
I
no.
mean,
This
how
is
do you
hard.
decide?
This is
Okay.
hard coded. 4x of T. It's a hard coded. Okay. So those people will be frustrated. This is the hard coded rule. Who decided? You can only decide T in this. R will be decided by your end user. Now, based on this, these people will be in the under satisfied bracket or tolerating bracket or frustrated bracket. You can't change the 4x. Okay.
Mhm.
Okay. So
But
so
is
far
that
so
like
clear?
a governing body which defines this 4x?
No, not required governing body. It's algorithm. It's a mathematics.
Okay.
See here, total number of traffic. Here, how much total number of traffic you got? Let's go for services. So total number of traffic for the 1 hour, total, what is this? So this many requests per second. So what is the total number? Let me see that. So for the 1 hour, I got 3.16 million total number. Correct? So out of this total number, how many people are satisfied? How many people are tolerating your application? How many people are frustrated? So T you set, system will get it, the APM will get it, and as per this total number, they will put it in a satisfied, tolerating, and frustrated inside a system. Are you understanding?
Correct. Correct.
Yeah. So are you comfortable with this so far?
So all these R and T is auto calculated, right? It's
Auto
not something
calculated.
where we are
No. T is
updating.
not, sir. T is not auto calculated. You set it up.
Okay, got it.
Yeah. Only R is auto. R is driven by APM tool. And this algorithm is automatically system defined. Okay.
Okay.
So now you understood that there are some people are satisfied with your application, some are tolerating, some are frustrated. Now the question was, what is Appdex score? So Appdex score formula is satisfied request plus tolerating request by 2 by total number of requests for that particular minute or 1 hour or whatever it is. So let's put it up. So if your satisfied request, apply simple. Your satisfied request is 100. That means tolerating request will be 0. Correct now? Okay. And by total number of requests. So your Appdex score is 0. Sorry, 1. 1 is the best score. That means your overall users are highly satisfied. If apply the same formula, if satisfied request is 0, tolerating request by 2 is also 0, that means everyone is frustrated in this case by 0 and your score is 0. That means worst score of your applications. So 0 and 1, and that Appdex score will be between 0 to 1 all the time. So where is the T you set it up? So guys, you set the T somewhere. Where is it? Here. You see that T, and here I define my T is 0.5 second, and that's the region. You know what? My reality, I mean, Appdex score for this R is very high. So you can set a little bit lesser. I don't think so it will make any change because my response time is in millisecond actually. Yeah, that's the reason. So my response time is in millisecond. That's the reason there's no changes happening. But if you have some real applications, it should be here. So Appdex score is yet to decide is 1. So can I put it up like this crazy number? This will not be realistic. Just I'm trying to change the value of Appdex score and make it 4 hours. See, a little bit reduced. Okay. So 0.1. Are you understanding, all of you? Hello?
Yes, sir. But there is a good chance that we can miss out on the a few users who are actually frustrated, right? Like, I'm just trying to understand.
Right.
According to your formula, there is no value for the frustrated users. You only have R less than equal to T and R greater than.
You did not understand. This frustrated user, tolerating user, satisfied user, which is stored in the system based on this R greater than and less than. And based on that, they will give you only score. Okay. So you set the T, automatically they will calculate and they'll give you the Appdex score. So there is no, you will not get a number of satisfied, number of tolerating, number of frustrated. Basically, by looking at this number between 0 to 1, you will come to know whether your people are satisfied or not. That's all. Be 0 to 1.
Yeah, I get that. I get the part, but according to this, so this tolerating request by 2, will that also include the frustrated users or no?
No, your frustrated users are all getting total in the denominator, right? Total number of users. So that is how your overall percentage will reduce.
And this is the fixed formula, sir. You cannot change.
Okay, one quick question, Rajesh. In this case, for a latency, can we consider T as a SLO set up by the product team?
Yes, that's a good number. That's a good observation. So T you can set saying that, hey, this is my application, I developed it. If it is a given this traffic, I'm expecting this response time will be in this much, and you set the T and get the Appdex. That's all.
Okay.
Really, and one more thing, there is some guidelines for setting up a T. I'm not discussing those ones, but be realistic. Let's say your application is loading in 10 seconds, but you are setting, oh, I am setting up the SLO for 1 second. That should not be there. That should be realistic number. Otherwise, your Appdex score will be giving you the fake statistics. Okay. Remember, it will not impact your anything in your application, but it will impact you to visualize the reality of your customer happiness. It's the basically customer happiness index, custom application performance index. You must be having, if you are in a this one stock market, you see the index, happiness index. Have you seen this happiness index? See, no. Stock. What do we call it? Anyone remember? Index for happiness. I mean, stock market index. Market index. I forgot the keyword actually. Index. No, not this index. There is a happiness. There's a fear index. Fear index. Got it. Fear stocks index. So there's one algorithm actually. Stock fear index. So if you see that here, there is also, they will tell you that whether this is the one. So there is a whole algorithm actually. So here it is. Okay, so like that, there's an index. The index is basically to tell you whether your customers are happy or not happy and all this stuff. Got it? Appdex score, all of you?
To some extent, I think some more reading is required.
Yeah. For us, if it is closer to 0, happy. If it's going closer to 0, closer to 1, happy. Closer to 0, not happy. In between, how much is happy, you can get to. So right now, mine is 99% happy. Remaining people are not happy. Like that. Okay. So here you can see the resources at each resources. You can see the request, total time, P50, 90 for each request actually. Errors, error rate, and also failure. Now here you can see the traces. Each traces you can see. You can research on the each traces which I talked about it. These are the request, and here you see that each call they will tell you. Right now I have not enabled the quad spot because it consumes lots of CPU. code hotspots when you enable, then what will happen? This for this request, what is the classes, method, lines of code got executed, that also will be shown here. So you have to enable with the source code hotspots. It will tell you which code is having problem and not. But this will create a lots of pressure. I mean, CPU utilization, RAM utilization will be very high actually. So you have to lose the resources accordingly. So all this thing you have it. Okay, so this is a APM. This is a profile, continuous profiler. I have not enabled it, but if you have a complex application deployed, you can enable this one also and get going. Okay, so any questions on understanding this particular UI, all of you?
No questions at this point, but there's definitely a lot of information. Like someone
Yes,
said. Yeah,
that's true, ma'am. See, this is the something I'll tell you in a simple way. We get into the observability having all this knowledge in place, like platform knowledge, runtime knowledge, application knowledge, and then all the terminologies and all. So that is something which we needed. So this is others. Remember that here you get every sort of data. If you understand, then only you can help the team to get it and properly get it done. Okay, so here you see the environment. You can filter by environment, you can filter by operations, you can filter by versions, and dashboard I'll talk about tomorrow. Service info and software. So play with this dashboard. The more, it's not dashboard by the way, it's this page more, and more you will understand this. You can play with this here, and you can right click here and double click here, and then see that related traces for that particular time, related containers for that particular time. And here this container means it's not a Docker container, servlet container also is there. And correlated to matrices means how it's correlated to the matrices, CPU utilizations, RAM utilizations and all. So with this APM, we are searching for the area of interest. So this is the correlations. Okay, so now I'll ask you everyone to go each and every options which is available here, experience it, see that, and after that, once you comfortable, do let me know. If you have any doubts also, you can do let me know. I'll give you 30 minutes for this. Go ahead, guys.
Rajesh, where should we go traverse through to see the Appdex?
Appdex will be on a front page only. Front page. The moment you click on the services, that's place only you will have it. Right side, you have to. Right side means last graph.
Latency graph.
Latency graph. Yeah.
So it is showing by default in percentile. So we need to change anything here to get the Appdex.
You can change maximum T. Rest of the things automatically detected. But even though if you change the T, because your response time is in microsecond, that's the reason it hardly impacted.
Got it.